Hi everybody, this is the pre-AMC video 1 in the video series for SaMi. I'm Olivia, and let's get started. Okay, so we want to make, for the first problem, we want to make the statement true. So let's figure out what the question mark needs to be replaced by. So we've got 6 question mark 3 plus 4 minus, and then we can already do what's 2 minus 1, right? So that 2 minus 1, that becomes a 1, and we know that that equals 5. Okay. So what's next? So we don't know what happens with the 6 minus 3, so that's still isolated. But we can do the 4 minus 1, right? So we've got 6 question mark 3 plus 4 minus 1 is 3 equals 5. Okay, and then lastly, we can put the 3 to the other side of the equation, right? So we can subtract 3 from both sides of the equation. Now we have 6 question mark 3 equals 2. Okay, so 6 what 3 equals 2? Well, it's not adding, right? It's not subtracting. It is dividing. 6 divided by 3 makes 2, so that is our answer. All right, good job with that one. Let's move on to the next one. Okay, what is the degree measure of the smaller angle formed by the clock at 10 o'clock? So 10 o'clock is going to look something like that. Pretend that it's 10 o'clock and not 9 o'clock. So we need to figure out the angle between all of our numbers, right? So we've got a 12 here, 6 here. Let's pretend I can draw a clock. So we know that our clock is a circle, right? So it's got 360 degrees in it. And there's 12 numbers on our clock, right? 1 through 12. So that means between each number is going to be 360 divided by 12 degrees. Doing that division, we get 30. So at 10 o'clock, we have little hand at 10, big hand at 12. So we've got one number between the 10 and the 12. That's the 11. So we know it's 30 degrees between 10 and 11, 30 degrees between 11 and 12. Adding them together, that's going to be 60 degrees between the two clock faces. So for this one, and I encourage you to pause the video if you need to read through it all the way, we want to figure out which 3 numbers don't have a sum of 1. And the sum, that needs to trigger in your brain, oh, I see sum, that means addition. I need to do addition. So let's add some numbers. Okay, let's start with A. 1/2 plus 1/3 plus 1/6. So for that, we need to make some common fractions, right? So I see 6. All 2, 3, and 6 are divisible by 6. So we get 3/6 for 1/2, 2/6 for 1/3, and 1/6. So let's add that. 3 plus 2 plus 1, that's going to be 6 over 6, which equals 1. So that does equal 1, so it's not what we're looking for. What about B? 2 minus 2 plus 1. 2 minus 2 is 0, plus 1 is 1. So B is not what we're looking for either. What about C? 0.1, 0.3, 0.6. That's going to give 1.0, which is the same as 1. Okay, D. 1.1 minus 2.1 plus 1. So, minus 2.1, that's going to give us negative 1, right? Okay, and then plus 1, that equals 0, right? Negative 1 plus 1, that's 0. We want something that doesn't sum up to 1. 0 is not 1. So in this case, D is our answer. Cool. Let's keep going. After 4 hours, how many more miles has Alberto hiked than Bjorn? So let's look at our graph. So here we can see at the 4-hour mark, that's along this line right here, we see that Alberto, he's hiked 60 miles, right? So A has hiked 60. And Bjorn, he's a little lower, right? He's only at the 45 mark. He's right there. So Bjorn is 45. So basically what this question is asking is how much more is 60 than 45? And how would we figure that out? Well, 60 minus 45. And be sure to take your time. It's okay to write it down. No shame in writing things down. 60 minus 45 gets you to 15. So that is our answer. And 10 feet wide is enclosed by a fence. To make the garden larger while using the same fence, its shape is changed to a square. So let's see. How much fence do we have in total if we know that it's 50 feet by 10 feet? So if we want to figure out how much fence there is, we need to find the perimeter. And remember, the perimeter is when we add up all the sides, right? So we've got a 50-foot side, 10-foot side, and then 50-foot and 10-foot. Adding that up, that's going to get 120, right? Okay, so if it's changed to a square, that means all 4 sides have the same length, right? So all 4 sides are the same. So to figure out how long all of those sides are, we can divide our 120 by 4, right? Because of the 4 sides. Doing this division, we figure out that our new square of the fence has side length 30. Nice. So by how many square feet does this enlarge the garden? That's basically asking how much bigger is our new area of the square than of the rectangle, right? So we see our rectangle was 10 by 50. That's an area of 500, 10 times 50. Here we've got 30 by 30. So 30 times 30, that's 900. So how much bigger is 900 than 500? 900 minus 500, that makes 400. So D is our answer. Moving on. Ooh, Boko, Flo, Joe, and Mo. I'm not going to say that 10 times fast. They draw different amounts of money. So neither Joe or Bo has as much money as Flo. So Flo has more money than Joe, and Flo has more money than Bo. Okay? Bo and Co have more than Mo. So Bo has more than Co. Or not more than Co. Bo has more than Mo. Co has more than Mo. Okay? Joe has more than Mo. Joe has more than Mo. But less than Bo. That's getting a little confusing. Who has the least amount of money? All right. So let's try to make an equation. Well, process of elimination. So we know that Flo has more than Joe. So Flo can't have the least amount, right? We know that Bo has more than Mo. So Bo can't have the least amount. And Co has more than Mo. So that can't be it either. Also, Joe has more than Mo. So that means Joe doesn't have the least amount either. So that only leaves Mo to have the least amount of money. Okay. Moving on. So third exit is at milepost 40. So here let's draw mile 40 has the third exit. We'll put number 3. And the 10th exit is at milepost 160. There's a service center located 3/4 of the way. I'll say that's the service center. At what milepost do we expect to find this? Okay, so let's think about that. So we want 3/4 of the way between 3 and 10, or between 40 and 160. So between 40 and 160, we've got 120, right? 160 minus 40, that's a distance of 120 between those two. Okay, well, what's 3/4 of that? It's going to take some fraction multiplication. So remember, 120 times 3 divided by 4, that's 360 divided by 4, which is 90, right? And then adding that to mile 40 says that our service center is going to be at about the 130 milepost. That's our answer. Okay. The face, we want to find the face opposite the white face. So in this case, we've got a cube. And this one's a little hard just because this involves a lot of visualization. So it's really hard to draw it out. But let's try to do some process of elimination, right? So we know that because y is next to the white face, so it can't be y, right? Because it's next to it, not across from it. Also, if we imagine this cube being folded, O is going to be next to the W, right? They're going to attach to each other. They're not going to be opposite. And the same is true with G. Okay, now we've got R and B. So know how to explain it other than just to like say to visualize it. We know that W is attached to Y and B is attached to Y. So they're attached to the same things. W is attached to G, B is attached to G, B is attached to O, W will attach to O. So because they're attached to the same thing, they have to be opposite each other. So that means B is our answer. And then if you don't see it right away, try to just draw it out and see if it works. Okay? Here we've got 3 flower beds. Let's draw this out. A has 500, right? So there's 500 in all of this area, right? B has 450, C has 350. A and B, so this little intersection, that shares 50 plants. A and C share 100, so that's 100. And we want to find the total number of plants. Okay, so a way to tackle this is we want to figure out how many are in each separate compartment. So we know that A and B, so where they meet, that has 50. So how many are in just B, not A and B? Well, you might want to say that's 450, right, because of this. But that includes the 50 that we already counted that are in both A and B. So the amount that's just in B is the 450 minus the 50 we already counted. So that's 400, right? And then for A and C, we know that they share 100. So how many does C have total? Well, C has the 350 minus the 100 that we already counted, right? That 100. So we take that out and we get 250 that are in just C. Okay? And we know that A has 500 plants, but we've already counted 150 of them, right? So the 500 minus 150, that's going to be 350 plants that are just in A that we haven't already counted. So let's add that up. How many plants are there in total? That's 350 plus 450 plus 350. That is going to be, no shame in writing it out, 1,150 plants. We have a complete traffic cycle light. Takes 60 seconds. So it's green for 25, yellow for 5, red for 30. So what's the probability that at a random time the light will not be green? Okay, so when is it not green? Well, it's not green when it's yellow, so that's for 5 seconds. It's also not green when it's red, right? That's another 30 seconds. So for 35 seconds, that's the time when it's yellow, and the time when it's red, that's when it's not green. So 35 out of any 60 seconds, that's when it's not going to be green. So it's 35 out of 60. We can simplify that, right? 35 and 60 are both divisible by 5. Divide them by 5, we get 7 over 12. That's the chance that at any given time it's not going to be green. So we've got 5 numbers placed that way. We want to find the largest possible value for the horizontal or vertical sum. So we want to maximize our addition. Okay. But we also need to make sure that the 3 numbers, so when you add the horizontal column, it equals the sum of the vertical column. We also want to maximize. Okay, so let's think about it. We could put the 13 in the middle, right? If we put the 13 in the middle, then we have 4 and 7 and 1 and 10 to balance it out. So that would give us a sum of 24. Ooh, that's pretty good. That's like one of our top choices. So let's keep that in mind, but also ask, can we do any better? Okay, well, if we put the 10 in the middle, that already doesn't work, right? Because 4 plus 7 won't add up to 11. There's nothing that's going to add up to the 13 on one of the ends. So 10 can't be in the middle. What about 7? If 7's in the middle, then we've got 4 and 10 and 1 and 13. Well, that adds up to 21, right? So that's not as good as when 13 was in the middle. What about when 4's in the middle? 4's in the middle, then we've got, I don't think that works, right? Nothing in the middle, the other two won't add up. Okay, so that doesn't work. Okay, what about 1 in the middle? If 1's in the middle, then we've got 7 and 10 and 4 and 13. That adds up to 18. That's not enough. 24 is our answer, and none of the other choices work because we accounted for them. Nice. The ratio of the number of games won to the number of games lost is 11 to 4, and there's no ties. So what percent of the games did the team lose? So we know that they lost 4 games. And they played 15 games, right? Because they won 11 and they lost 4. So adding that up, that's 15 games that they played. And we want to figure out what percent that is, or as close as we can get, right? So we want to find what that is over 100. So I'm going to use cross multiplication for that. So basically, what we do for cross multiplication, if you're not familiar, which is okay, we do 4 times 10, so that's our crosses, or 4 times 100, sorry, that's 400, and then we divide it by 15, so the other cross will get us our mystery. So we've got 400, that's the 4 times 100, divided by 15, 2, 30, 10, about 6, and we get some remainder. So looking at our answers, what's the closest one? It's going to be 27 because our answer is just over 26. So that's to the nearest whole percent. Continuing on. Got the average size of the 40 members of the camp. 20 girls, 15 boys, 5 adults. Average age for girls is 15. Average age of boys is 16. Right? So if 17 is the average, that means 17 times 40, right? Because for the average, they're all going to add up. So you add and divide for the average, right? So that means that whatever the number that all the age added up to divided by 40 is 17. So if we do 17 times 40, we can find out what the average added up to, what all of the ages of the boys, girls, and adults added up to. Okay, so that's 20 times 15 for the girls, and then 16 times 15 for the boys, plus 5 times adult average for the adults. So we want to figure out what the average age for the adult is, which means you're going to have to solve this system of equations, which I encourage you to pause the video and do now. And what is it? That is answer choice C. Doing the math, that's 28. And this is one of those time sink problems where it just takes a while to solve. That's okay. Sometimes it is like that. Okay, next question. We want to find the perimeter of our trapezoid. And we know side AB and CD are equal. Cool. So, let's see. If this is an 8 and this is a 16 and their sides are equal, that means that this portion of space, that's going to be, well, it can't be 8, right? So it's the 16 minus that's in the middle, so that's 8, and then it's half of the leftover space. So this is 4, right? This is 4, here's our 8, and here's another 4, and that adds up to 16. And then, but to find the perimeter, we need to know this length right here. Well, how can we find that? Well, we see that here we have a triangle with leg 3, leg 4. So some of you have heard of a 3, 4, 5 triangle, you would know. But otherwise, you can do Pythagorean theorem. 3 squared plus 4 squared is 5 squared. So that is a side length of 5. Adding everything up, we've got 8 plus 16 plus 5 plus 5. That is 34. Oh, sorry. So here we've got some license plates. And we see that the first choice can have either CH, LP, or R. So that's 5 choices for the first letter. Second letter has 3 choices. And the third letter has 4 choices. Right? And so now we're told that you can either add 2 letters to one of the spot possibilities or 1 letter to one spot possibility and 1 letter to another. So that means we could either have 7, 3, 4, 5, 5, 4, 5, 3, 6, or some other combination like 6, 3, 5, 6, 4, 4, or 5, 4, 5, right? That's the 6 ways to do it. So basically, we want to figure out which one of these is the biggest, right? And so that's kind of more like a guess and check. But we can already eliminate a few things. So 5, 4, 5, and 5, 5, 4, those are the same. So we only have to figure out one of those, which is helpful. And otherwise, I think we're just going to have to do some bashing. So 534, that's 20 times 3. Here's 60. That's our original, right? 734, we've got 21 times 4. That's 84. Already an improvement. That's good. 536, 5 times 6 is 30, times 3 is 90. 635, same thing. 644, that's 24 times 4, ends in a 6. You know what, you guys? No shame in writing it out. Just saying. 96. Okay? And then 545, 5 times 4 is 20, times 5 is 100. All right, so looking at our answers, we can see that 545 is going to be the greatest increase, but we want to know how much bigger that is than our original combination, which is 534. So originally, you had 60 possible license plates. Now there are 100. That's an increase of 40. So an interesting about this is that my answer is correct, and the answer key says that it is correct, but D is not the right answer. So that's really fun. Pretend it says 40. This is a typo or something went wrong on the test year. 40 is the correct answer. It just wasn't one of the answer choices, which happens sometimes. That's okay. Try not to think too hard about it, and we'll just move on from there. All right. Here we've got Tori's math test. So 75 problems, 10 are arithmetic. Always helpful to write things down. 30 are algebra. Sometimes you need to change your variables. And 35 are geometry. So she answered 70% of the arithmetic, 40% of the algebra, and 60% of the geometry. Okay, and says she got less than 60% of the problems right. So how many more questions would she have needed to answer correctly to earn a 60%? So let's figure out how many questions she answered right. So it says she answered 70% of the 10 arithmetic questions. So what's 70% of 10? Well, 70%, that's like 70 over 100. We want to see what that is over 10. We can see that we can do some simple division. So to get from 100 to 10, you divide by 10. So we can divide 70 by 10 to figure out our common ratio. So we know that Tori answered 7 arithmetic questions correctly. We also see she got 40% of the 30 algebra questions right. So we want to find 40% of 30. We can see that 10% of 30 is 3, right? Divide by 10 to find 10%. Multiply it by 4 to find 40%. So that's 12 algebra questions. And 60% of the 35 geometry questions. So we can divide by 10 again. Divide the 35 by 10, 3.5 to get 10%. Multiply by 6 to get the 60%. That's 21 questions. Okay, so that means that Tori got 7 plus 12 plus 21. That is 40 of the total 35 plus 30 plus 10, 75 questions correct. Okay, and she wanted a 60%. So that's 60 over 100. So what percent does Tori have right now? Or actually, even better, we can find a shortcut. What's 60% of 75? So we can say 75 divided by 10, 7.5, that's 10%. Multiply by 6 to find 60%. That's 45 questions. So Tori needs to answer 45 questions correct to get a 60%. And she answered 40 questions right. So that means she needs 5 more questions, right, to get from 40 to 45 to be correct. All right. Moving on. So we've got 108 students. So we've got 15 cookies per pan. Always helpful to keep the details in mind. So we want to buy, so Walter can buy eggs by the half dozen. How many half dozen should he buy to make enough cookies? So how many cookies does he need to make? So 15 cookies. And we know that needs 2 eggs. 108 students, we need to make 216 cookies. Let me pull up my drawing thing. 216 cookies. So we know one recipe makes 15 cookies. So how many total times the recipe will he need to make? We'll do 216 divided by 15, 66. So that means he'll need to make just over 14 times the recipe. So rounding up, because we can't have people without cookies, that'd be really sad. We need 15 times the recipe, right? Because we're not going to be making half recipes or partial recipes. So we need 15 times the recipe, and each recipe needs 2 eggs. So that means we need 30 eggs, right? 15 times 2. And it says here, Walter can buy eggs by the half dozen. And this is important. If you don't already know, it's okay. Dozen, that is 12, right? So remembering when somebody says a dozen, you're thinking 12. So half a dozen, half of 12 is 6. So how many boxes of 6 eggs should Walter buy? 30 divided by 6, that is 5. Answer choice C. And we did it. Okay. Next question, same prompt. So they learn that a big concert is scheduled for the same night. Oh no. And attendance will be down by 25%. That is unfortunate. So we know that originally we wanted to make 216 cookies, but now we're going to lose 25% of that, which is just sad, but I guess we're going to have to deal. So 25%, something helpful for me is it's a lot easier for me to visualize if I think about that in a fraction, right? So 25 over 100, that's equal to 1/4, right? Just like 25 cents is 1/4 of a dollar. That's the same thing. So if we're losing 25%, we're losing 1/4 of 216. So let's figure out how much that is. 216 divided by 4, 54, right? So we're gonna have 54 less people. 216 minus 54, that is 162 total people. So how many recipes of cookies should they make for the smaller party? So each recipe makes 15 cookies. We need to make 162 cookies. 162 divided by 15. So it is 10 with some remainder. That means we have to round up, right? 10 with some remainder rounds up. We're going to need 11 recipes. That is answer choice E. Okay, and finally, the drummer gets sick. This concert is just full of turmoil, it seems. But that's okay, life happens. So the concert is canceled. Walter and Gretel must make enough pans of cookies to supply 216 cookies. There are 8 tablespoons in a stick of butter. How many sticks of butter will be needed? So we know per recipe, there's 3 tablespoons, right? And so we know from the first problem that to make 216 cookies, that was 15 batches, right? 15 batches, and we need 3 tablespoons of butter per batch. So 15 times 3, that is 45 tablespoons of butter. Dang. Okay, and 8 tablespoons of butter makes a stick. So how many sticks are going to be needed for this recipe? We divide it by 8. 45 divided by 8, that is 5 and some change, right? 40 and then 5/8 are left. So because of that extra bit, we're going to need to round up because we can't get partial sticks of butter. We can't get 5/8 of a stick of butter as much as we may want to. So we're going to need 6 sticks of butter. Answer choice B, that is the correct answer. So let's draw it out based on what we have. Okay, so we see on the bottom left is a 1. So that means in front we've got 1 cube. Cool. Next, we've got 3 cubes next to it. 1, 2, 3. Draw that out. And then another 1 cube. Then behind it, right, we've got 2 cubes. I can't really show depth here. So just imagine behind it, there's 2 cubes behind the 1 cube. 2 behind the 3 cubes, which I'm not going to draw because that's not very easy. And then behind the 1 cube, there are 4 more cubes. So horrible to visualize, but you're going to have to do your best under test prep conditions. But basically, the only thing you're going to see in the front view is the tallest part of it, right? So in figure 4, we've got 1 cube in front of 2 stacked cubes. What you're going to see is the 2 cubes, right? In the next one, you've got 3 cubes in front of 2 cubes. You're not going to see the back 2 cubes. You're only going to see the front 3. So we're looking for something that has 2, and then 3, and then the front view finally has a 4, right? Because that's the only thing you're going to see in a front view is the 4 cubes, not the 1 cube in front of those 4 cubes. So 2, 3, 4, that looks the most like B, and that is our answer. Okay, the degree measure of angle A. Okay, we're going to have to deal with some complementary angles. Always fun. So, I'm going to draw a bigger version. Let's just do some pretending here. So, we see that any straight line, something important to note, is that this angle here, it may not seem like an angle because it's a straight line, but that angle is 180 degrees. So straight line, 180 degrees. It may help to remember that that is half a circle, which is 360 degrees, if that makes it easier to visualize. So in this case, we've got a 100-degree angle here. So the other part of that straight line that continues on over here, that plus the 100 is going to add up to 180, right? Because they're part of the same straight line. So that angle on that side right there, that's 80 degrees. What else can we work with? Well, we've got 110 degrees here. So adding it up to this side over here, 110 plus something is going to have to add up to 180. That would be 70 degrees here. We have a 40 degrees down in this corner, and now we have a triangle, so that's helpful. We've got a 40 degree here, 70 degree here, and then some mystery angle. Remember, just like the straight line, the triangle also adds up to 180 degrees, right? So if we got a 40 and a 70, that's 110, plus our mystery angle has to add up to 180, so this is another 70 degree angle, which would be right here. Okay. Now, what we can do is we have an intersection, right? Here's a 70, and what's across from it is going to add up to 180, right? Same straight line, so that is 110. And then across from that is another 70, because the 70 plus the 110 have to add up to 180 for the straight line. Okay, now we're close to finding angle A, because we have our 80 degrees, our 70 degrees, and our angle A. 80 plus 70, 150, plus angle A makes 180, so 180 minus 150, that is 30 degrees for angle A, option B. Okay, some ratios. So we know 3 fish equals 2 breads, okay? And 1 bread equals 4 bags of rice. So how many bags of rice is 1 fish worth? Ooh, okay, let's see. So if 3 fish is 2 bags of rice, and 1 loaf of bread, and 1 loaf of bread is 4 bags of rice, let's see if we can make one entire equation, right? That combines both of the ones that we have. So our top one has 2 breads. If we multiply the bottom one by 2, right, we'll now have 2 breads equals 8 rice, which is the same as 1 bread equaling 4 rice, right? So we can say that 3 fish equals 2 bread, and we know that 2 bread equals 8 rice. Perfect. Cutting out the middle just to find the ratio of rice to fish, because that's what we're asking for. 3 fish is the same as 8 rice. Okay, so how many bags of rice is 1 fish worth? We can divide both sides of our equation by 3, right? 3 fish divided by 3 makes just a fish, equals 8 bags of rice divided by 3, 8 thirds. Simplifying, that gives us 2 and 2 thirds. Answer choice D. So Square has side length 3. CM and CN divide the square's area into 3 equal parts. How long is the segment CM? Okay, so let's fill in what we know. So side length 3. 3. So what's the area of our total square, not the 3 segments? Our total square has area 9, right? 3 by 3. So that means each of our segments has area 3, right? Equally divided. So we want to find the segment of CM. And we can do that if we find the length of BM right there, and then use Pythagorean theorem to figure out CM's length. So let's see how that's going to work. Well, we know that CBM here, CBM, has area 3. And it's also a triangle. So base times height. So BM, that segment, times 3 divided by 2 equals 3, right? Base times height over 2 equals the area. Solving for BM, we get BM times 3 equals 6. BM equals 2. Okay. Now using Pythagorean theorem, we've got 3 squared plus 2 squared is going to equal our hypotenuse, which is CM squared. 9 plus 14 makes 13. CM squared equals 13. Taking the square root of both sides, square root of 13 equals CM. That is our answer. All right. We want to find the remainder when 1999 is divided, or to the 2000th power is divided by 5. Okay. So, something important to note. I do not want to find 1999 to the 2000th power. That sounds horrible and really time-consuming and just not at all fun. So we're going to find a shortcut because bashing this would be actually the worst. So 1999 to the 2000th power. How could we figure out just the relevant parts that we need? Well, we're dividing it by 5, right? So that means that only the units digit is relevant. We're just asking for the remainder, right? So if it ends in 8, we know the remainder is 3. If it ends in 6, we know the remainder is 1. It doesn't matter what the rest of the number is. We just need to know the last digit. So that helps us out. So we know that the last digit of 1999 to the first power, that's 9, right? We can see it there. What about the last digit of that number squared? I also do not want to square this number. So let's just consider the last digit of that. So we've got 9 is the last digit of 1999. Multiplying it by itself, because we're squaring, that gives us 81. So that is our last digit in that case, right? Because our tens digit, when you square it, is not going to contribute to the units digit when you multiply. Okay, what about 1999 cubed? Well, we can multiply our 1 from the squared by another 9, and we get 9. Oh my gosh, it looks like we've got a pattern, right? The first power is going to give us 9. Second power gave us 1. Third power gave us 9. Fourth power, if we keep going, will give us 1 again. And on and on and on. Okay, so what's going to be the last digit of 1999 to the 2000th power? Well, we can notice that odd powers, so to the first power cubed, they both end in 9. And even powers like 2 and 4 end in 1. And this is always going to be the case, right? We've got a continuous pattern. So 2000 is an even number, right? So that means that 1999 to the 2000th power, it's going to end in 1, right? Just like all the other even powers. So when you divide 1 by 5, the remainder is 1. Okay, moving on. Okay. Oh my gosh, it's a lot to look at. So we're seeing midpoints. AC is 6. CG is 6. Okay, so looking at this, we can see a pattern, right? So in this trapezoid right here, we notice that that all of these triangles inside that look the same, right? And the same is true for this next trapezoid. All of those triangles look the same inside the trapezoid. So what that's showing us is that the shaded region is only taking up like 1/3 of each of those trapezoid regions. And since the trapezoid regions make up the entirety of the large triangle, the shaded region is going to take up 1/3 of the entire area of the large triangle, right? Okay, so what's the area of the large triangle? We know it's got base and height 6, so its area is 6 times 6 divided by 2, which is 18. So the 1/3 of that, 1/3 of the area, 18 divided by 3 is 6, and that is our answer. And that is it for the practice questions. That's it for the test. Good job, everybody. Hope you got something out of it, and have a great day.